Okay. And the first thing on delete cascade, what exactly it was? Now see. On delete cascade, when I'm using this, okay, to my child table, what it was happen? Okay, now you can see. So once we delete a row from a parent table, then the corresponding child rows are also deleted from child table automatically. So once we delete a row from a parent, then the corresponding child rows also deleted from your child. And this will be happen automatically. It will be deleted by deleted from your child table. Okay, right. So let's take one small example on this, how we can use this and how it will work. So the previous whatever we taken out, the same example, I just take it now. Okay, but now the table names I'm changing now, department 2 and same as usual. And to insert your 2 records, then after here I will take employee number 2, ID primary key, name varchar and department number into references. Now this time 2. And on this reference column, it's nothing but foreign key column. You should apply, what is this your rule? What is the rule? On delete cascade. And remember, on delete cascade rules are, we are applying only child table, not parent. Okay, now? So because we need to address to child, not a parent. That's why you can apply this. Okay. And after same as usual, you can insert your EMP2. Some values you can insert. So, and 20. Okay. So let me see here. The same thing I just go for to my database now. And the first one, I'm creating department number 2 table because duplicate names are not allowed here. So that is the reason your table names must be different. So I just commit to permanently saving purpose. Then after child table, so on delete cascade we applied here. And a few records you can insert into your child table. And one more. Okay, right. And I just committed. So after that, let's come out and see your parent and child. So DPT number 2, it's parent table, EMP number 2. And every parent is having one child. So Java is having one child, Oracle is having one child. Now, after on delete cascade rule, once you apply, what it was happening, you can see delete from parent table DEPT2 where department number is equals to 10. Same thing yesterday also we did, but it was showing error. But now after cascade, what it was happening, you can see. Parent deleted, huh? Yes. But parent is deleted, okay. But this rule, what it was tell us, once you delete a parent, automatically child also deleted. Deleted, huh? Yes. This is on delete cascade rule purpose. Right down below. Right down. Completed. Hmm. This is on delete cascade. And the same as one more rule is there. That was we called as on delete set null. This rule we are using guys here, the purpose here observed. So once we delete a row, okay, from a parent table, then the corresponding child rows are are child rows of a foreign key column of a foreign key column. Values are converting to null in child table automatically. Okay, right. So now the example you can observe. For this, same to same, I just take it out now. This time again, I want to change my table name. Number 3. So you can pass like this. So employee 3. Are you taking references from 3? And on delete set null. Then after you can give it 3 and 3. The same operation you can. So let's see here once, okay. Once you just come out and to execute this one, table created successfully. And we want to insert here the first second row also. I'm going to insert it now. So after that commit, then after the second table, okay, with on delete cascade, null I'm using now. So it is also done. And same as the 2 statements we want to insert now. 2 or 3, any number, okay? For this is just for testing purpose, I'm taking here the 2, but you can use and commit. So after committed again, so call to your tables, select a star from DEPT number 3 and EMP number 3. Okay, right. And now you can see delete from DEPT number 3 where department number is equal to, suppose I'm going to pass 20. Something is missed. What is this? Dnum. Dnum is equals to 20. So deleted here successfully. And later you can come back to your 20 was deleted from parent, but 20 corresponding child row or child record not deleted, but foreign key column value will be changed. Row not deleted, child row is not deleted. So instead of delete, what it was happen, that specific foreign key column values are converting as a null. Okay, now this is on delete set null, right down below. Okay, completed. So these are the two cascades whenever you need to break your deletion rule. But insertion rules, we cannot break it. Okay, now? Right. But here, carefully observe your unique not null check primary foreign key. So we applied on the table, that's okay. But sir, I want to see on this particular table which type of constants are you applied. Those constants details I want to view now. Okay, now, for example, when you come back to your database tables, if I just call it now, tab, there are so many, almost 24 tables are there. In out of 24 tables, just I want to know about on the registered table, are you applied any constant or not? How I knows? On registered table, are you applied constants or not? Otherwise, this table is having any constant or not. How as a programmer, I know it. And this kind of doubt you are not getting? Sir, I want to see my constants details. The which constraint I was applied on which table and which constraint I was applied on which column of table. Okay, na? So these kind of information, how I can view it, sir? How I can see it, sir? Okay, na? So that kind of information, if you want to view, you can't directly go for, suppose some people thinking that, can I see desk? Okay, what is the table name? Registered. But if you want to see, this is just for your structure of table only showing. It means how many number of columns, each column is having what type of data type, it will be show you. But I don't want it this. I want it here what now? Suppose I have it 3 columns now. On 3 columns, are you applied any constant or not? If it is applied, then what it is? Suppose registration number is having some constant. If that you know, okay? If you know some constant is there on registration number column, then if it is there, then which type of constant that is? That is primary key constant, unique, not null, check, foreign key, default. How I want to know it? The constants details. Okay, na? So, and suppose in this any one table, if I'm asking, suppose EMP table is there. On EMP table, do you have any constants or not? DPT table is having any constants or not? Like student table, like items one, like test one, like test two. So any one table, constants, whether it is there or not there, if it is there, what type of constants are there? And those constants on which columns are you applied? So this entire the details, information, a programmer or user want to see or want to view. So this complete information where it will be stored by your Oracle. Understand na? As of now, we applied unique constants, we applied. Not nulls are applied. Checks are applied. Primary keys are applied. Foreign keys applied. All are applied, working, okay. But now I want to see those constants. Now I want to see those constants. Then this constants information, Oracle server, where it will store. Whether it is storing or not. If it is storing, where it was. Okay, na? So this kind of informations, if you want to know about particular table or something, there is a one concept was there. It's very important for your interviews. That is called a data dictionaries. Exciting. Otherwise, we called as a read-only tables. Okay, right. So now, what is data dictionary? And what kind of the informations are saved in this data dictionaries? What are those? How many types? This all we will check it out. So now, first of all, observe. Data dictionaries are we called as a predefined tables. Even though you can call system defined table also. And these tables are we are not created. Automatically, your system will create it internally. At what level? It means that at the time of installing level. So whenever a user is going to be installing Oracle software in your computer, along with installation, internally some predefined tables also prepared by Oracle or prepared by system by itself. And those tables we called as what now? Data dictionaries. That's why data dictionaries also tables, just like a tables only. But these are system defined, not user defined. Okay, now that's the first point should remember. And these data dictionaries or on these data dictionaries, user cannot perform DML operations. Suppose one data dictionary table is there, system defined table is there. On the table, a programmer tried to do some modifications like data insertion, data deletion, data updations. So these kind of things you need to perform. If you try to perform, it is not allowed. It is not allowed because data dictionaries are only for reading purpose. That means in the data dictionary table, what kind of information is saved? That information as a programmer, I can see, I can read, I can retrieve, but I can't perform DML. So that's why DML operations are what now? Insert, update, delete. These operations you cannot perform and it will not allow to you also. Okay. You can perform only select command. Select command, which purpose we are using? Data reading purpose. Reading is nothing but retrieval purpose. That purpose we are using select command. And with that command only supporting here. That's why data dictionary is called a read-only tables, but not write-only tables. Write-only, here one more point remember for your interviews. Some people indirectly they are asking write operations and read operations. If any interview person is asking, can you tell me about the write operations in database? What do you want to say? Yeah, write operations are nothing but DML operations. So many students are confusing. So that's why I'm telling that write operations are nothing but DML. Read operation is nothing but select. Read, write. These two are important for you. Like how your Java, in your Java, data reading, data writing, writing, reading. How it is important, same as in database also, reading operation and write operations. Write operations are three types: insert, update, delete. These are performing on table modifications purpose, table data changing purpose. You can use it. But read only selected. Just a data we cannot modify. But whatever the data was existing there, the data can be read only. I just read, but I can't do anything. That is called a read only. So your data dictionary is also supporting only reading purpose, but not writing. By that reason, people will called as a, these tables are called a read-only tables we called. Understand now? This is second point. Third point is what now? Okay, sir, we understand that data dictionary is also one table. Okay. But a table is nothing but storing some information now? Yes or no? Yes. So then data dictionary tables, what kind of informations are stored? Okay, now let's see here. For example, okay, your database is there now. Your database is there now. Okay, whatever your database is there now. So in this database, suppose are you designing one table? Are you designing one table? So this table information will store. Table information means what now? This table name, what type of columns are there, how many number of columns are there, that kind of information is also keeping under data dictionaries. Now on the table, if you applied any kind of facility, for example, just now we applied which facilities? Constant. Just now we applied which type of facilities? Constant. So now this is your table, sorry, database. In database, are you designing one table? This table information will be there. On this table, if you applied any kind of facilities, the facilities information also saved under data dictionaries. For example, as of now, we applied only one kind facility, that is constant. So what kind of constants you applied? These all constants details are storing under one data dictionary. That is called a DD1. I'm just telling that, DD1. Suppose on this table, in the future, we will see these all concepts. Okay, na? We are applying what now? Views. What is view? That all we will discuss in coming soon. These are all are called advanced topics we will learning. Okay, right. So if I want to create or applied view, then these views can be storing under one more data dictionary. Suppose are you applied on this table synonyms? What is synonym also? We will see all this. So this is this information will store under one more data dictionary number 3. Suppose like this, you applied indexes, you applied clusters, you applied sequences. Okay, you applied what next? We called procedures. We applied functions. We applied triggers. We applied packages. Whatever. There are so many different types of techniques, methods, facilities you are applying on your table. Okay. So whatever you applied, every individual of facility or mechanism, okay, that all will be storing into separate data dictionaries. Like you can go indexes are storing into one more data dictionary, clusters are stored into one more, and next sequences are one more, properties procedures are one more, triggers, functions, packages, like every facility information will save into that related data dictionaries. So like this, how many data dictionaries we have, sir? That means there are thousands of plus data dictionaries are available. Not only 1-200, there are thousands plus data dictionaries are available. And each and every data dictionary will store that related information only. For simple example, I want to tell you. If you go to library or librarian, what he will do? He will be storing or keeping the books in separate racks. Yes or no? There are some racks are there in the library. Each and every rack, he will already decided that this rack is completely history books. It means history related books only in this rack is available. One more rack is the comic books. So in that we are all having that comic books only. One more is called as a biographies, autobiographies or biographies. Those books are having that only. So that means why the librarian will maintain separate racks for separate books? Because easy to accessing purpose. Suppose when one customer will come to my library, he is asking to me, sir, I wanted comic books, sir. Then librarian will see the list. Okay, comic books are having in the rack number 3. So then he was telling to customer, customer, you can take that right, take direction state and left. There is a third rack is there. In the third rack, your comic books are available. So now what the customer will do? There are 10 racks are there. Are you searching 10 racks? No. Directly as per the guidance of your librarian, we are directly going to whom? Where? Rack number 3. So the rack number 3, directly I can pick whatever it was. Okay, now same like this, your data dictionaries. Here also, every dictionary is storing that related information. And if you wanted that related information, then you just go to that data dictionary table. Then only you will get an answer. Understand, na? So like constants purpose, one data dictionary. View purpose, one data dictionary. Synonyms purpose, one. Procedures purpose, one. Like so many data dictionaries are available in our database. So in this, all the database data dictionaries are we are having under one query statement. We can see that what it is. I will tell you. Write down for some points here. Okay. Now take the point. Whenever we are installing Oracle software, internally system is preparing some predefined some predefined tables are called as data dictionaries. These data dictionaries are are stored are are stored the information about tables, comma views, comma synonyms, comma indexes, comma sequences, comma clusters, comma procedures, comma triggers, etc. And here one more thing I forgot it. Add some point here, either last or what. No, what is this? Constants. Okay, right. And next one, data dictionaries. Data dictionaries are allowed select statement but not DML operations, so that these tables are called as read only tables. read-only tables. If we want to view all data dictionaries in Oracle database, then we follow the following syntax. The following syntax is, what is my syntax here? Let's see. The following syntax is select star from dict. And here dict is nothing but we called as here. A dict is nothing but it's called as a main dictionary. Okay. So these are the some information about your data dictionary now. Right. And let's come out and see this. So now you can come out and go for to this data dictionary, select what is this? Star from dict. If I executed this command and see, so there are 1,000 plus data dictionaries are available. So 1068 data dictionaries are available, and these are all are called as a data dictionary names like session underscore roles, session underscore attributes, yes or no? These are all are like lobs. These are all are called as a system defined tables or predefined tables or data dictionaries are we called. So many are there like this. You can see each and every one. So like there are 1,000 plus data dictionaries are available like a tab. Can you see the tab we are using? Yes or no? Select a star from tabs. So user histograms, user tables, user synonyms. See, this is synonyms. It will store synonyms information. It will store tables information. Like we have sequence information. Can you see recycle bin? Yes. Objects, indexes, like so many are there. Sessions, roles. Okay, so many are there here. Every data dictionary is having its own and related data can be saved. So can you see this is what? Dict. So now dict means what now? Dictionary. This is main dictionary. Like later we have a user underscore tab columns, clusters, catalogs. Okay, so many are there like. Okay, now these are all we are not discussing this all, but as per the concepts, we are discussing few data dictionaries and you can understand that what is what. Okay, now as per your topic and syllabus. So we are covering some data dictionaries here. Okay, right. So like you can go to see it now, right down below. Completed, huh? And now come to our example. One example we will see. What is the example? Okay. I'm creating one sample table now. Test number 8 or 9? 9. Test number 9. See carefully. One of my column ID. One of my column ID. It is called as a primary key. Okay, na? So next we have your a name, varchar 2 of some size. Suppose just I'm telling, okay, unique and not null. Unique and not null. Next we have some salary. It's called as number. Check of a salary which is greater than some, okay, 8,000 or something I was given. And finally close it. See here, on my test number 9 table, I was applied primary key, unique, not null in one column and a check. So I'm going to executing this. What is now here? Table is created. Table is created. Okay, now? So now table created successfully. That's okay, fine. That's okay, fine. But sir, are you designing as a developer? I designed this table and I'm sending to client. Got it my point now? Are you designing this table and sending to client? But when the client will use this table, when client was use this table, first he want to checking that on this table, is there any validations are applied by programmer or not? Is responsibility. You need to test. Yes or no? So client will testing that whether in this on this table, is there any validations are there? Or if it is there, which type of constants are applied? What kind of views are created? This kind of information they want to see. Okay, now present we applied only constants. We didn't apply any other things. So now the client want to view, because we are not giving the source code to the client. Just we are giving what now? Tables we are giving. We are giving just a tables, but we are not giving this entire code. Okay, now the entire script will be your side. So we are giving just a tables to the client. So client want to know on this table which type of constant was applied by developer, that he want to see it. So how you want to see it? Based on a data dictionary. The data dictionary is called as a user underscore cons underscore, what is this? Columns. But here, sir, okay, I know the data dictionary name, but with this name, what I can do? Because I want to know about, this is table name, okay. This is a data dictionary, table name, okay. But where is my data? Where is my constant? Constants are storing in which type of columns, where it is. This kind of information, do you want to see it? First of all, what you have to do first, this data dictionary is a table. One is confirmed. If it is a table, means compulsory having structure, na? Yes or no? When I see the structure of this data dictionary table, then only programmer or client can understand that, okay, these are the columns are having in this data dictionaries. Otherwise, without the structure, I can't do anything. Yes or no? I want to see first a structure. What type of columns are there in this table? That I want to see first of all. For that purpose, what should we do here? I need to use what? Desk. So that means before you want to know about your information by using of a particular data dictionary, first of all, as a programmer, as a client, in that data dictionary, what kind of columns are there? First, I have to see. But how I can see my columns information? Desk keyword, that I already know. So now I want to see the structure of this data dictionary I'm seeing now. When I was executed this one, what it was happening, you can see these are having the name and these are having the data types. Can you see? So now if you carefully identify, it's the same look like a table structure now. Yes. One side columns, one side data types. It same look like a what? Table structure. That's why data dictionaries are called a tables. Blindly remember. This is also table only, not any other object. It is also table, but system defined, not user defined. Okay, na? Right. So in this structure, what kind of columns we have here? Warner column, constraint underscore name column, table underscore name column, column underscore name column, position column. Total how many columns in this table? 5 columns. Suppose these all columns information at a time, if I want to see, I can use star. How to write? Select star from. These columns belongs to which table? User underscore cons underscore columns. That means select star from user underscore cons underscore column. Then all the details you can see it. No, sir, I wanted what now? Only constants information I have to know. Then what we want to use here? Constant name column. I have to pick column name. The column name, what is that? Which constant are you applied? Which column? Okay, that column. And next, what you want here? Table name. Which table? Test 9 test 1 test 2 test 3 EMP registration table department table student table which table constant you want to see? Which table constants you want to see? That is called a table name. Understand now? Let's come out and see. Now I'm going to using. So what I want to say, select. First I have to take column underscore name column. Next, what is what here? Constant. So constant underscore name column from these two columns enough for me. From these two columns belongs to which table? User underscore cons underscore columns. Okay, but up to here, if I leave like this, what it was happened in your database, how many number of tables are there? That all tables constants details are displayed. But you want it all tables constants information or specific table constants? Specific table. Specific table means which condition? Where condition. So you need to apply where. Where, what is the next column? Table underscore name is equals to. And which table name you want to see? Test 9. So I have to go test 9. Concept clear? Now on test 9 table, which type of constants are you applied? That information client you can seeing now. Now he was going to be see now and he was entered. He was entered. It was showing what now? First one, column name. Second one, constant. What is my first column? E-name. On E-name, you applied one constant. But the constant name is which format? System defined format. And it is having here number format. And this number, who was created? System. So that's why can you see in my first example only I said, there is some sys underscore some number is came. I said this number is called a constant identity number. So what is this number? In future classes we will discuss, I said. Okay, now the part is come out. See. So these are all sys number, salary column some number, ID column some number, name column some number. So now, okay, that constants information is showing like this. But tell me, now I'm a client, you are a developer. You are sending your table like this to me. And I'm checking your constants, what you applied. But these constants are showing to me in which format? Number format. If it is a number format, as a human being, can I understand? No. Suppose here one constant is there. Here it is showing constant on e-name column and e-name column. Here one number 96, one number 99. In these two IDs, which is unique, which is not null? Can we identify or no? No. Why, sir? Because it is a number format. Maybe Oracle server can understand what is what. Because it will create it. System is created. System can understand what is 96. 96 unique, not null, system knows. Unique, not null, system knows. But user doesn't know. Why? Because these are the number format. So once you design your constants on a table like this, immediately client will reject your tables. In real time, client will not accept it. Immediately client, I'm a client. What I can say? Array, what are you developed here? I didn't understand. Go and take remodify and give me as a user defined understandable format. Which format? User understandable format I wanted. So immediately what I can say, I didn't understand what you applied. So just take your tables back and show me the constants with the user understandable format. Then only I can understand your table, what you applied. Okay, now? So that immediately send back to the client. So that means what I want to do, my constants names, whatever it was showing in system defined format, this is not acceptable in real time. That's why in place of system defined constant ID name, I want to create a user defined constant IDs. And those IDs, if my client or my programmer, my colleague, my team lead, my project lead, whoever see, they can easily understand. Okay, on e-name column, he was applied a unique constant. Okay, on salary column, he was applied a check constant. So that kind of easiness, and that means clear information we need to give our client. Then client will be happy. Understand or not? But that means what we want to do, convert into user defined. How I want to convert this constant IDs into user defines, right on below. So below I'm writing the statement after that. We want to view the constant name along with column name. If we want to view the constant name along with column name of a particular table, of a particular table, then we use a data dictionary. A data dictionary is called as user underscore cons underscore columns. And below, you just prepare like this: desk user underscore cons underscore columns. And next one, what we taken here, the formats. Completed. Hmm. So now these are the way, or this is the way to see and your constraints. Which constraint are you applied on particular columns? But here one thing is observed when we are interacting to the data dictionaries. Okay, now your table name I said now. So your table name must be in capitals. Okay, suppose if so many people at practicing time, you are using small case characters. Okay, now if I'm using your small case characters, test 9, it will not show anything. Understand na? So that means what do you understand here? My table name must be in the capitals only when we are interacting with the data dictionaries. So this point just underline here. What do you say here? Table name should be in capital. Okay, now? Right. But how this is will store internally, you're careful observe. So internal operation, that means internally how it will be means. Uh, this diagram also you can prepare for your understanding. So this is your database. This is your database. First observe. Okay, now? For example, this database name is mydb 6 p.m. In this, we are we are having so many data dictionaries. But in this one of the data dictionary, I'm taking now. With our selected, as per query, our selected columns only I'm taking. Okay, now? Not 5 columns. I'm taking our selected columns. This is we called as, okay, now? Right. Our data dictionary name. What is this? User underscore cons underscore columns. And these are our column names in this table. Table underscore name. Column underscore name. What is this? Constraint underscore name. First, my table, test number 9. My column EID. What is the number for EID? Sys C 008. Huh? 1% tell me. 8496. Okay. Next, test number 9. We have e name. What is that? Huh? Sys underscore C 0084996. 197. First one, EID 96. EID 98. EID 98. 9, 8. This is 9, 6. Huh? I believed you. You are telling wrong. Huh? 9, 6. Second one, sys underscore C double 0, 8, 4, 9, 9, 9. Okay, now? Yes. And the next one, test 9, salary, SYS, C double 0, 8, 4, 9, 7. This is internally your data dictionary, sir, how it will store your constants. Take this diagram. This is called as what now? Data dictionary. Complete? So this is internal storage of every data dictionary table will store particular information. Okay now? Okay, right. Okay, right. These are what dictionaries information and user define how to create. We will see tomorrow. Okay, no? So tomorrow I will show you how to design your user defined constant names. Okay, right, guys. Thank you. Thank you so much.